This is video 5.4.1, which introduces the sum to product and product to sum formulas that goes along with section 5.4 in your book. So we're working with some lengthy formulas. It's going to be really important to distinguish who's alpha, who's beta, and then to work with the values carefully. So the first ones we're going to look at are product to sum. So this is going to take, so taking a look at these formulas, this is going to take something that was a product and it's going to turn it into something that's a sum or a difference, but a difference can be written as a sum, of course. So it's going to take something and it basically breaks it up into two pieces. We're also going to see where we do the opposite. We take a sum and turn it into a product later in this video. So we're taking a product of two sines, different angle values, and it turns it into a difference of two cosine angles, remarkably. And the explanation behind these formulas is in your book. But here's how we work with them. And remember, these are important skills to have in order to solve equations later on in the chapter. So sine of 2x, cosine of 3x. So first I want to distinguish that alpha is 2x and beta is 3x. So in order to use my formula, I have to find the correct formula. Looks like I'm going to use this one. And I had to distinguish who's alpha and who's beta. So I'm going to take this and it's going to be equal to 1/2 of the sine of the sum of alpha and beta, so 2x plus 3x, plus, looks like I'm going to do the difference, so alpha minus beta, 2x minus 3x, all in that big bracket. So I can simplify this out just a little bit. 1/2 of the sine of 5x plus the sine of negative x. And that's all you do. That's how far you take it. It's as simple as that. This is going to be helpful once again. Once we have some numbers, you're going to see why this is helpful. It gives us exact values for certain different equations. So let's take a look here. Once again, we have sine of 3x, sine of 2x. So we have an alpha and a beta. Pick which one's which. And then we're going to use the formula. Now we're going to use the first formula up here in order to solve this one. So we're going to get the sine of alpha, so the sine of 3x. Oh, hold on, sorry. We're going to get 1/2 the bracket of the cosine of, let's see, alpha minus beta, so 3x minus 2x, minus the cosine of 3x plus 2x. And in simplifying this out, I get 1/2 times the cosine of x minus the cosine of 5x. That is all you're going to do on that one. Once again, that's fully simplified. So these are looking a little weird. You're probably wondering why we're doing this, but get used to them, be comfortable with them, so that we can solve equations with them in the future. So you'll see where these come in handy. This one we're going to see coming in handy when we want to try to find the exact value of the following expression. Now, we know 5 pi over 6 is on our unit circle, and so is pi over 3. But what's interesting is there's other ways to find these exact values using this formula. So we can get the same exact answer that would be on our unit circle as we will using the formula. So we're going to use the formula again. It looks like we have alpha is here, beta is here, and we're going to use the last equation. So we're going to have 1/2 of the sine of the sum of the angles, so 5 pi over 6 plus pi over 3 minus the sine of alpha minus beta, so 5 pi over 6 minus pi over 3. Okay, so it looks like I need to work with some fractions here and change some things to common denominators. So pi over 3 can be written as 6 pi in 6th as 2 pi over 6. So I'm going to change that in both spots here so that I can do the math and simplify the expression. So I have 1/2 of the sine of, it looks like 2 pi over 6 and 5 pi over 6 makes 7 pi over 6 minus the sine of 3 pi over 6. Subtracted those two there. Okay, so now I'm going to look to my unit circle and find out what these values are. So 3 pi over 6 is the same as pi over 2. I know that's 90 degrees, and at 90 degrees the sine is 1. So that value is going to be 1. The sine of 7 pi over 6 on my unit circle, that's the angle that's going to be down here, pi over 6. So let's see, the sine will be negative, and it will be negative 1/2. So we have negative 1/2 minus 1, minus coming from up here, and we have 1/2 of that. So it looks like we're going to have 1/2 of negative 3/2, which also equals negative 3/4, which is my final answer for this particular example. So these will help us find exact values. Now this one wasn't as helpful, but you'll see in your next checkpoints as well as the next example how to find exact values of things we don't know. Now sum to product, very similar formula. It's basically we've rearranged some things and moved some things back and around. The more complicated part of the formula is now going to be the input angle here. You have all these fractions that you see. And we have a very simple expression to start though. So let's take a look at this and how to use that in a couple of examples. Example 3, express each sum or difference as a product. So these are just like the first example. We're going to start with just taking this and recognizing who's alpha and who's beta and figuring out what formula we're going to use. So we're going to use the first formula because we're adding two sines. So we're taking the sum of two sines and converting it to 2 times the sine of the sum of the angles divided by 2 times the cosine of the difference of the angles, so 2x minus 3x divided by 2. And simplifying this out, I'm going to have 2 sine of 5 pi over 6. So, sorry, 5x over 6. 5x over 2. Goodness. Cosine of, let's see, negative x over 2. And that's as simple as I get. I leave it there, and I'm good to go. Now cosine 42, cosine 148, perhaps we'll actually be able to find the exact value of this expression. So taking a look at what formula I'm going to use and who's alpha and who's beta, looks like I'm adding 2 cosines, so I'm going to use this formula, and alpha is 42, beta is 148. So we have the cosine 2 times the cosine of the sum of the angles divided by 2 times the cosine of the difference of the angles. So 42 minus 148 divided by 2. So we're going to have 2 cosine of 190 over 2, or 2 cosine of 95. And then I'll have, I still have this cosine here, 142 minus 148 is negative 106. So I'll have the cosine of negative 106 all over 2, or the cosine of negative 53 degrees. Now I'm going to clean this up just a little, knowing that the cosine of a negative angle is the same as the cosine of its positive counterpoint. That is an even odd identity that is in the back of your book. So I'm going to change this to 2 cosine of 95, cosine of 53. That is equivalent. You can double check in your calculator to make sure you believe me, but it's an even odd identity in the back of your book. Now I don't know if 95 or 53 or anything about those angles, so I'm done at that point because I can't find the exact value. But this one, we're actually going to be able to find the exact value. So we've worked with 75 degrees before and learned how it's 30 plus 45, and we've learned formulas to break it apart that way. And we know 15 degrees is half of 30, so we've used 30 to help us with that, or 45 minus 30. But there's another formula now that we can use in these circumstances. So we have cosine plus cosine, so we're going to use this formula here. And we have, we're going to see what comes about when we do that. We're going to have 2 cosine. Oh, let's see. This is alpha, this is beta. So we're going to have 2 cosine of the sum of the two angles divided by 2 times the cosine of the difference. So 75 minus 15 over 2. So let's see where this takes us. 2 cosine of, it'll be 90 divided by 2, or 45. So we have 2 cosine of 45. Well, we do know the cosine of 45, so this is looking promising. Cosine of 75 minus 15 is 60 over 2. And then once again, we know cosine of 30. So now this one I actually can find an exact value. So I'm going to do that by looking to my unit circle and seeing that cosine of 45 is square root of 2 over 2. And also seeing that cosine of 30 degrees is square root of 3 over 2. So I'll work this out, multiply across the top. Let's see, I can simplify a little, cancel those 2's. So it looks like I'm going to get square root of 6 over 2. And that's the exact value for that original sum of cosine of 75 plus cosine of 15. So you could do a problem like that using your sum and difference formulas, but now we have another formula that might come in handy, we might recognize as an opportunity to use earlier on. So I'm going to give you a shot to try some of these in your checkpoints. You have 2 checkpoints. The formulas are listed there, so use them wisely and carefully. Don't get stumped, for instance, with this one by the fact that you have x over 2 and 3x over 2. Just figure out which one's alpha, which one's beta, and then carefully work with them. I promise you it'll get a little bit simpler. And once again, remember when we work with radians like we do here, sometimes we're better with degrees. So changing it to degrees right now is not a bad idea. Definitely do that. If you want to improve your fraction skills, try using them as is and seeing if you get the right answer that way. Bring your questions into class and we'll go over them when it is due.